Okay, then I'm going to write the topic for you so you can see it again. Solving systems by graphing. Solving systems by graphing. This is the topic we are going to study in the chapter 5. Now I need to start with the example 1. Okay, maybe we can read the theory. The theory, where is the underlined part? That's the important part. A system of linear equations is a set of two or more linear equations containing two or more variables. A solution of a system of linear equations with two variables is an ordered pair that satisfies each equation in the system. So, if an ordered pair is a solution, it will make both equations true. Okay, both equations you want to solve, you want to find the solution, find the value for x and y, they are related. So if you find the values for the, both of them, then they are going to be a solution. They are going to make the both equations true. Okay, so the solution of the first one is going to make the other one true. It's going to be the solution of the other one because they are related. Okay, you use both of them to find the solution. Okay, in a system of equations, it couldn't be, it could be more than two. It could be 2, 3, 4 equations. Okay, it's not a limit of this, but we are going to work with the easiest one. We only have two equations, so we find a solution. In the example 1, we need to identify a solution of systems. So in the example 1, I'm going to write it in here. We need to identify. They write identifying, but we don't, okay, we don't need everything, but I'm going to write identifying solutions of systems. I'm going to, okay, expand this so you can see it better. In the exercise A, what we have in here is for the order pair for 1, you can see that they give you the value for x and the value for y. I don't know if I can draw in here the, okay, no, it's for drawing the key you have in here, okay? But I'm going to use then this one. I'm going to use this one twice to show you because in some I cannot draw something like this. Okay. So the first equation you have is x plus 2y equal 6. And the other equation you have is x minus y equal 3. Okay. This is a system of equations, okay? You have two equations, they form a system. This value they give you for x and for y, they are the possible solutions. So we are going to prove that these values satisfy the equation. How can I prove this value satisfy the equation? I'm going to replace. Then I'm going to replace the value for x and the value for y. Substitute 4 for x and 1 for y in each equation in the system. So I'm going to write in the two equations. The first one we have is x. I'm going to give more space. X plus 2 times y equal 6. And the other equation we have is x minus y equal 3. This is what we have in here, but we need to replace the value for x and for y, and you need to prove if the solution is correct or not, okay? I have x is 4. 4 plus 2 times y. What is the value for y? 1, this has to be equal 6, and you can see that it's going to be 6, right? 4 plus 2, we have that 6 equal 6. So this ordered pair 4, 1 is going to be a solution for this equation. Now we need to know only if this is going to be a solution for the second equation, and if it's a solution, this is going to be the solution for the system of equations. If it's the solution for both equations, it's going to be the solution of the system of equations. And the only way to know this is proven with the values of the variables. X is 4, again, minus y, that is 1. This has to be equal 3, and you can see that 3 is equal 3. This sentence is always true, sorry. This sentence is always true, so you can say that this ordered pair is a solution for this system of equation. Then the ordered pair 4, 1 is a solution for the system of equations. So you prove it, and when you prove this, you need to say if it's a solution or not. In this case, I'm saying that it's a solution because I prove that this makes my statement true. 6 equals 6 and 3 equals 3, okay? This has to be true. If you obtain something false, it's not going to be true. If you find, for example, a statement that you are not sure, for example, if it's going to be true or not, so you cannot say that it's going to be a solution. Then for the, okay, in the book they write that this make the both equations true, so the pair is a solution, but you can say it in that way. The ordered pair is a solution because you already proved it, okay? Now in the exercise B, in B we have again the ordered pair. Look that they give you the ordered pair because in this you are only identifying, but in the other examples, when we graph, when we substitute, when we do the procedure, you are going to find this solution, okay? In the book they are not going to give you. If they give the solution, okay, it's a plus. It's only to replace the values. But the idea is that in this chapter, you'll learn how to find the solution of these systems of equations, okay? At least using the 3 methods that we are going to study in here. And B, we have -1 for X and 2 for Y. And the equations we have, the first one is 2x plus 5y is going to be equal 8. And in the other equation, we have 3x minus 2y equal 5. Okay, then we have the 2 equations, and what are we going to do? We are going to prove if this value for x and for y, if this ordered pair is going to make these equations true, okay? Then if the value make the equations true, we are going to say that it's a solution for the system of equations. I give you the space in here so we can work. I'm going to expand this. Then we have that in the first equation, 2 times x plus 5y is going to be equal 8. And for the other equation, we have that 3x minus 2y is going to be equal 5. Then what are we going to do? Replace only the value for the variable. For example, in the first one is 2 multiplied by -1 plus the value of y multiplied by the number 5. 5 times 2. This has to be equal 8. If this statement is true, this has to be equal 8. Okay. In the other one, 3 times x, 3 times -1, minus 2 times the value of y. The value of y is going to be 2, right? This has to be equal 5. So this is what I have in here. I need to prove this. I replace for x, sorry, this is -1, not 2. 2 is for y. The minus is from the equation. You can see in here that is from the equation. And this has to be equal 5. Then we are going to prove if this is true. 2 times -1 is -2, plus 5 times 2, that is going to be 10. This has to be equal 8. So you can see that it's true, right? -2 plus 10 is going to be 8, equal 8. So in this case, these values for x and y make this equation true. Now I'm going to prove with the other one. This is -3 minus, okay, -4. 2 times 2, that is 4. This is going to be equal 5. So you can see in the book they write the order pair -1, 2 makes one equation true, but not the other one. So what are you going to write on the equation at the end? Sorry of this. I'm going to write the solution, and later I'm going to write what you need in here. The ordered pair -1, 2 is not. Okay, I can write like this, is not. But I want you to mark this part. So that's the reason why I separate. Is not, because you can see the word not, a solution for the system of equations. And if you want to write more, if you want to justify your answer, it's okay, because it makes one equation true, but not the other one. Okay, just one equation is true when you prove these points, but the other one is not true. So this ordered pair is not a solution because it has to be a solution for both equations. Remember that these two equations are completely related. They are working like they are the same, okay? They are working in a system. So if you find a solution, the solution has to be for your system, not for only one equation of this one, okay? So then we can say that it makes one equation true, but not the other one. And in the other part, you can have this, check it out. Maybe you want to try. Tell whether the ordered pair is a solution of the given system, okay? In the page 330, we have a little part of a theory. Maybe I can explain you this. 330. All solutions of a linear equation are on its graph. To find a solution of a system of linear equations, you need a point that each line has in common. In other words, you need their point of intersection. Okay, you can see the graph in that part. Maybe, okay, we have some minutes, 3 minutes only to explain you this. This is the y-axis and the x-axis, right? This is for x and this is for y. I don't want to waste much time doing this because the important part is to show you what is the solution. Then you have something like this. You have a graph that is starting in here, for example. I thought that I changed the color, sorry. Okay, you have something like this. And for the other one, I'm going to use red, like in the book. And it's going to intercept like in this point, I think. I'm going to draw it in here, okay. So the point of intersection is this one, where both equations okay, have a point in common. They are going to intercept one with another. So this point in common that they have is going to be your solution for the system of the equation. This point you have in here is going to be your solution when the both graph intercept, okay? Because remember, the solution for the system of equations has to be a point that is on both equations. So the point has to be in this graph, and this has to be on this other graph. Do you understand that part? Okay. If you only have, for example, you have the blue part. In the blue part, imagine that this is a system of equation, and I draw other line like this. They don't have any point in common. So if you find one point for this one, it's not going to be a solution for the other one. So you understand the idea of this? When you graph a system of equations to solve, it's because you want to find a point or in common, okay? One point that has to be in one graph and the other one. In this case, the point 2, 3 is where the two lines intersect, and it's a solution, okay? Only that they show you another graph, okay? I draw a different graph only to show you what represents the point of intercept, the point where they intersect, okay? So then, guys, I'm going to finish in here because tomorrow we need to continue with the graph. We need to continue tomorrow with the example 2 and 3. Then I'm going to finish recording the class, and I'm going to give you some time if you want to ask something.